point of time, don't worry about it. It is like assume some Google Drive or some API, something like that. It is from something like that. APIs, SFTPs, or some email. Emails also the contains the files. These might be various source systems from where we will be getting the information. That information we have to put it into some database. Uh, this process, the process from getting the source till the target is what we do in the data engineering. So our roles, our daily roles include so data ingestion or extraction from various source systems. Data engineering roles includes extraction, transformation, and loading. So this is what we call as ETL. So data engineering involves building ETL pipelines. Building ETL pipelines. So this process we can do with any kind of tools. This process, there were n number of tools which each organization is using, but the main thing we have to know here is Python, SQL, and cloud. These three things are mandatory. With these three things, we can do any ETL pipelines or any data engineering job, but the tools and technologies for each organization may differ. So I will tell you in detail how each of it will be used at what step, what technology we will be using. I will tell all of this. So mostly, if we have some experience around 3 to 4 years, not into data engineering, any kind of thing, and if you learn these technologies, there are so many opportunities. Like data engineering is one thing, and consultant data engineering, there are different roles, and sometimes data engineering is also referred to as a data analyst in some organizations or based on the roles, because the analysis includes mostly about the data. Whatever we do, it is all about the data. So in some cases we'll be doing analytics also. So data engineering or the data analytics, these two are the roles which we will play in the organizations. So we can apply for both of them by looking. If we know Python, SQL, and cloud, you will be easily or comfortably do any kind of data engineering job. More than anything, I can say SQL is the most important thing which we use in our daily life as a data engineer. Without SQL, we won't be able to do anything. It is like alphabets. Without alphabets, we can't be able to read English. So similarly, without SQL, we can't do data engineering. So these are about the what we do in data engineering and how we have different opportunities in the uh, industry. So now coming to the technologies or the tools what we have to use, the main thing is SQL. So the database might differ. Some organizations might be using MySQL and some of them will be using the cloud data warehouse and some of them will be using something else. But whatever it is, the database, out of the database, we will get data by using only the SQL queries. You should be expertise at the SQL. We should be able to write complex queries, everything. You should be good at SQL. It comes by practice. SQL is must. This is mandatory. So how much ever you are comfortable with SQL, that much you will be able to feel comfortable with the data engineering job. So SQL, we can say 60% of our job moves around this SQL only. And next, Python. Python is the next most important thing, but you should not be that much expertise in Python. If you are able to understand what is the existing code and if you are able to make some changes, because in every project, whenever we join organization, it will not be from scratch application. It is already built application, but on that already existing application, we might have to do some enhancements or write similar type of code like that. So we don't have to be very expert at Python. It would be better if you are expertise at Python, but at least the basic understanding or understand the existing code and make some changes. That is what is expected here, Python. We should be good at Python. Other than that, we should be good at any of the cloud. So coming to the cloud, we have three major clouds. One is AWS, Amazon Web Services, and the other is Azure, which is provided by Microsoft. The other is GCP, Google Cloud Service. Most of you will be aware of like Google Cloud. Like, I mean, we in our phones, I mean, in our mobiles, we will be storing the photos in the Google Drive. That is also a kind of the Google Cloud service. That is like a storage service. Similarly, we can do that in AWS or Azure. Uh, the storage names will differ. I mean, we in all of these three cloud technologies, we have n number of services. Each of it will differ. I mean, storage we can call S3 in AWS, in in Azure we call it as a blob storage. In GCP we call it as something else. So the names will differ, but the purpose is same in all of the three clouds. So in current days, most of the organizations are using Azure or the AWS. If you're good at any cloud, you can relate it to the other cloud platform. If you are good at AWS, you can relate it to Azure or the GCP. The functionality is same, but the terminology, the names will be little different. So even in the cloud also, in AWS, if you consider AWS, there are hundreds of services in that, but we should not be good at all of them. We have few services which is relevant for our role. That is like we should be good at storage. You can take any cloud. If you go with any cloud, we should be good at storage and the data warehouse, because these two are the most important things which deals with the data. Storage is like we can store our files or the data. In AWS we have S3. In blob storage, in Azure, we have blob storage for storage. For storing purpose, we are using in AWS, we have S3. S3 is nothing but simple storage service. Simple storage service. There are three S in that, so that is why it is called S3. And in Azure, it is called blob storage. And there is also one more service, Azure Data Lake Storage. And similarly, we have in Google Cloud Storage, Google Cloud Storage. So coming to the data warehouse is like it is a database where we can do all the data modeling or the data transformations, applying the business rules. All this we can do it in a data warehouse. So in each of these cloud services, we have a different data warehouse. I'll say in AWS we have Redshift, and in Azure we have Azure Synapse. It is not mandatory that if we are using AWS cloud, we should only use Redshift. Nothing like that. We can use any external data warehouse also. It is all supported on any cloud. So in Azure, we have Azure Synapse, Azure SQL. We have so many things in Azure. So in GCP, we have BigQuery. So if you're familiar with any of the cloud and any of the storage, if you are good at AWS, let us take S3 and Redshift. So you will be able to relate it to the blob storage, and also you'll be able to relate Redshift with the Synapse or the BigQuery. At least we should be familiar with any of the cloud. But that architecture, there is a little difference between the architecture, but most 80% of the things will remain same. The functionality is same. So in data warehouse, other than these three cloud provided services, we have one more cloud data warehouse, which is called Snowflake. Cloud data warehouse. This is Snowflake. It is not specific to any cloud. It can be hosted on AWS, Azure, or GCP. It can be integrated with any of the cloud. And this is the most booming data warehouse nowadays, I can say. So we have roles explicitly for Snowflake data engineer. If you are good at Snowflake and SQL, you will get a job also. So, but Snowflake, you have to be very good at architecture. I will tell you all those in our course. In Snowflake, you have to be good at architecture and all the features available in that Snowflake, uh, along with the ability to write complex SQL queries. So we have the roles like Snowflake data engineer or the Snow. So there will be roles only for the Snowflake itself. So Snowflake is most important cloud data warehouse. We'll be covering this in our course. I will show you how it should be hosted on AWS, it should be hosted on Azure. Any cloud I can show you with the practical how to load the data into that. So this is about the cloud, and in other than this storage and the data warehouse, we will be also using some organizations, not everywhere, for building ETL pipelines. For building ETL pipelines in AWS. Sorry. So someone is talking. Can you please be on mute? Okay. So for building ETL pipelines, in AWS, we have a service called Glue. Glue is used for building ETL pipelines. We can do transformations in that, apply business rules in that Glue. Inside the Glue, we can write either Python script or the PySpark script. I will tell you what is PySpark, don't worry. So Glue is used for building the ETL pipelines. So in Azure, so same ETL we can build in Azure using ADF, which is nothing but Azure Data Factory. Azure Data Factory. So these are all optional. You can go with any of the services. Each organization, it will be different based on their setup or the requirement. It will be different whatever they use. So in in AWS we have Glue, and in Azure we have ADF, Azure Data Factory, to build the ETL pipelines. So now, so Python, we have two things here, two programming languages here. One is Python and the other is PySpark. So we should know when to use Python and when to use PySpark. Python is basically to deal with the small volumes of data. If our file sizes are in only MBs, not in GBs, then we can go with the Python, small volumes of data for processing data. I mean, we don't just use the basic Python. We have a library called Pandas. In Python itself, there are n number of libraries. One of it is Pandas, which is used to deal with small volumes of data. And PySpark, if the data size is so huge, I mean, if the file sizes are in gigabytes, so then we will go with the PySpark. PySpark is used for big data processing, large volumes, or the big data processing. So this PySpark, where it can be written, I mean this PySpark where it can be written inside the Glue, or inside, there is a one more technology called Azure Databricks. Azure Databricks. So here also we'll be writing either Python or PySpark code. So we can write our transformations in AWS Glue or the Azure Databricks. Or if we don't want to write a code, we can use Azure Data Factory. Azure Data Factory is codeless. There is no coding concept here in the Azure Data Factory. It is all drag and drop options. But most of the times we there will be a necessity in our real-time projects to use either Python or the PySpark. Only with the data factory we will not be able to build the pipelines. We should be good at least one programming language, either Python. Without Python, we will not be able to learn PySpark. PySpark is like a Python version of the Spark. We have Spark environments, Apache Spark environment. This is supported on Python. That's why it is called PySpark. PySpark is like advanced level of Python, which does the parallel processing of the data. That is why, see, if the data is in GBs, it will split the data into some small partitions, 100 MB each partition, and it will do the parallel processing. That is how the data processing will happen faster in the PySpark. But on Python, it will all be continuous execution. I mean, one step after the other. That's why Python is not used for the large volumes of the data. So we should be good at least Python, if not PySpark. PySpark, it is not mandatory. If we want to go with the big data, then we have to learn PySpark. If you're good at Python and Pandas, you will be able to understand PySpark. Without Python, we can't learn PySpark. So that is one thing. Now, so other than these are all cloud services or the cloud technologies, and these two are the programming languages. Other than this, there is a tool called Airflow. Airflow is a orchestration tool. Orchestration means building ETL pipelines. Build ETL pipelines and also automation. So with this Airflow, we can define which job has to run after what, and also at what time each job has to run. All this we can set in the Airflow. Airflow is the orchestration tool used to build ETL pipelines and also for the automation purpose. Without, if you don't want to use these cloud technologies, I mean, Glue, cloud is mandatory. I'm not saying that data storage and data warehouse, these are the mandatory things without which we cannot do data engineering. But this coming to Glue area for the data bricks, if you want to skip this, we can go with the Airflow. Uh, if you want to use Airflow, we should be good at Python. Anyways, whatever the technology or whatever the tools you use, Python and SQL are mandatory. So if you want to go with Airflow, we should be some expertise. We should be at some expertise level on the Python, without because Airflow is all about Python coding. So this is it. We can. I will tell you the some sample uh, demonstration, like how the data will be, what steps are involved in that. I'll walk you through that. Now we have covered all the services. So Uh, now assume that we have data from various sources. We have done all the rules, I mean, extraction, transformation, loading, and applied business rules. All these things we have completed. Now that uh, in that pipeline, there might be some failures expected. So there might be some bad data coming in due to various reasons. The jobs might fail. So this is all automated, but the jobs will fail because these jobs will be running on a daily basis or a weekly basis or whatever it is. The jobs might fail for any of the reasons, but who should be looking at that? Who will be taking care of those failures? So for that also there will be a separate role called production support. In the data engineering itself, we have a production support or the batch monitoring roles. Production support or pipeline monitoring. There will be a dedicated team to take care of the production support. I mean, in any kind of project, there will be a production support, but the data engineering, the pipelines will run continuously, so that there should be a dedicated person who will take care of these failures. Because if the pipelines will not run as expected, if there is any breakage in between, so at the end of the day, the business people or the stakeholders will be looking at the reports generated by these pipelines. So if there is any issue, then at the end of the day, the users will come and say, what happened to our reports? Why the report did not generate today? So those reports are very important to the business people, because based on those reports only they will be taking the business decisions, or any kind of enhancements to their business. So the end goal is that our data should provide some insights to the business stakeholders. So um, now that our data is in data warehouse, from the data warehouse, analytics team will consume the data. Analytics team means either Power BI or Tableau or any kind of analytics reporting tool. So those people will be consuming the data, our data. So that there will be some pipelines after the data warehouse, which will build some reports using Power BI or Tableau or any reporting tool. So if there is any issue in our pipeline, their pipelines also will get affected. So that's why we have an explicit role called a production support or the pipeline monitoring jobs. So while building the pipelines itself, so there will be hundreds of pipelines in any of the projects. So if even though if there is a dedicated person who will be supporting this, he should not be going to every job and see if this is running fine today or not. That manual effort should not be there. So in the automation process itself, there will be setting some alerts whenever there is some issue. It should send that alert to messaging channel with either Teams notification or some email notification or some Slack notification. That is how we will get to know the errors. We'll be taking care that in the pipeline setup itself. So on a high level, this is what the data engineering looks like. What these are the technologies we have to be aware of. Now I'll explain you how the project looks like. Any questions still here? Okay, if no questions, I will move ahead. Okay. So, as I said, the data engineering involves data extraction from various sources. As I said, the sources will be first part is data extraction. Data extraction from various sources. This can be done using Python in case of small data and PySpark in case of big data. So this is where Python comes into picture in our data engineering. So data extraction from various sources. The sources will be anything. It might be API, SFTP, or emails, and it can be anything. So next, after extraction, we have got the raw data from various sources, and now we have to clean it or transform it. Cleaning or transformation. I mean, if there is any bad data, we have to remove it before loading it into our data warehouse or the final consumption. So we call those steps as the data transformation. Data transformation. So ETL, in the ETL process, this is first step. E stands for extraction and T stands for transformation. So data transformation. Here we'll be involving data. So from the raw data, it might be strings or numbers or the date columns or whatever it is. We should be converting them correctly. I mean, if it is a string column, we have to specify a string. If it is a date, we have to convert it to the proper format. Uh, in most of the situations, date columns will be coming like year, month, date, or month, year, date. It will be in random format. So we have to make it consistent. Data type conversions we have to do here. Clean the raw data. Or if there are any rules implementation, we can either do with Python pandas or Snowflake. After loading to the data warehouse, we can do it there as well. And applying business rules. This is all done with pandas, Python pandas or the PySpark. If you are going with Python, we can use pandas or PySpark. If it is a big data, we will go with PySpark. So till here, extraction and transformation we'll be doing with Python or the PySpark. So now we are good with extraction and the transformation. So we have extracted the data from the source where we should keep it. We have to store it in somewhere. So after this, we have to store the data into store, transform data.
Geeta, I have one question.
Yes, tell me.
So when you are saying PySpark, big data, is it Hadoop data you meant to say, or it's any huge data in the sense
Any
you
huge data which is not in CSV, Excel or JSON format. CSV, Excel, and JSON also we can read it with PySpark, but the Parquet files, which is some semi-structured data, unstructured data, large
Okay.
volumes of data, any large volumes.
Okay. Okay. Got it.
Yeah.
And we'll be connecting to SFTP servers or
Yes.
okay. Okay.
Because Python supports various libraries to connect to SFTP or any source. There are packages by default in Python which will connect to that.
Okay.
Yeah. Because of
Even
the
even
yeah.
PySpark allows to connect to DBs, right?
Yes,
Yeah.
PySpark mostly for connecting to DBs or reading the Parquet files in S3 location or the blob storage location.
Okay. Okay.
Yes. So now we have to store the transform data in any of the cloud service, cloud storage. Store transform data in cloud storage, either it be S3 or blob or Azure data lake. You can store it in any of these places. Before transformation, before transformation also the data will be stored, because in future if something goes wrong, if we want to look at the raw data before transformation, we should have access to that. So in that case also we should be storing the raw data. We'll store the raw data along with the transform data in the S3 bucket. The S3 or the blob storage, the cost is less, so we can store the any amount of the data. It all depends, the storage at the extraction part or the transformation part. It will all depends on the organization or their setup or their architecture. So after storing in S3 or any cloud storage, we won't be able to do any analytics from the cloud storage. It is just for storing the data. It is like a Google Cloud photos where we can store our photos, but we cannot do any, I mean, any analytics or the right SQL queries or do complex joins on that. So in order to do that, we have to load the data into data warehouse. Load into data warehouse. This is where our data warehouse comes into picture. This data warehouse will be either Snowflake. In our course, we will be covering Snowflake because Snowflake is most used technology nowadays. It is supported on all cloud environments and it has advanced features compared to the other inbuilt cloud data warehouses like Redshift or Azure Synapse or the BigQuery. These are specific to each of the clouds, but Snowflake, it is generic for all the clouds. It can be used using any cloud. So load into data warehouse, which is the Snowflake or Redshift or anything. Azure Synapse or BigQuery. So the data warehouse is like it is integration of all the source systems. Data warehouse is integration of all the source systems. Then only we will be able to do analytics. I will tell you what it is. Integration of source systems. So now, as I said, the data will be coming from various sources like API, SFTP, or sometimes it will be on-premise data warehouse as well. On-premise data warehouse, on-premise database, sorry, database, or anywhere. It might be coming from any place. So the same data, I mean, the same business data, either it is a banking data or any investing data or whatever it is, the same data will be coming from different sources. So let us say we have a banking customer. Let us say ICICI is sending data from SFTP. HDFC Bank is sending data through API, and another bank is sending data through on-premise. So we have different banks which will be sending data to us. So for we have to store all this data at one place. Then only we will be able to identify which bank is performing well, which is not performing well. So that's why in our data warehouse, integrate all the source systems into one place. And here we will be applying some business rules again after loading. After loading, we'll be applying some business rules here as well. Apply business rules or calculate aggregates. Aggregates means the monthly metrics or the yearly metrics. Monthly, how much revenue is generated. Monthly, how many new customers are there. Those kind of calculations we will do it here. Calculate aggregate or metrics. Metrics in a sense, I mean, how many customers, how much revenue. These are all comes under metrics. We can calculate all these things. And after calculating, this data is used by analytics team. So now we have done extraction, transformation, and loading. Load into data warehouse comes under loading. So we have done all these three. ETL process is now built, but we have to automate it. Extractions, somebody will not go and trigger this Python script. Somebody will not go and keep the files in S3. Similarly into data warehouse. So nobody will go and run these things. It should be automated on a everyday basis because the data keeps on coming continuously, and this all this process should happen continuously. Continuously in the sense maybe once an hour or once in a day. Based on our business implementation, we have to decide that. So for automation, and also we have to define after which job what has to run. First extraction has to happen, next transform, next load. Otherwise, if these jobs runs randomly, there will be no use. That's why we have to set. That is called orchestration. Orchestration that we can set with either Glue, AWS Glue, AWS Glue or ADF. Here I have written. We can do that automation with any of this Glue or ADF or the Databricks. So orchestration. Automation can be set with anything, and also most ideal thing for this is Airflow, because Airflow is open source and it can support any kind of Python code or any language. We can say any language, any data warehouse. It has n number of operators, just like a Python libraries. And for orchestration, mostly we'll be using Airflow. So for automation, it depends. Any technology, any tool we'll use. Here we use Airflow for automation. So now our job is completed. We have extracted, transformed, load, and automation is also done. And as I said, there will be monitoring production support team who will take care if there are any failures. So till here is our job. Now I will tell you what we'll cover in our course. The first thing is SQL. From basic to advanced, we can cover, and Python. Python, whatever is required for our data engineering. Basic Python, advanced Python, along with the pandas. Python, SQL. These are the mandatory things without which we will not be able to do anything in the data engineering. So coming to the cloud. Cloud, I'll be covering Azure data. In Azure, we have various services. Uh, I'll tell you what all I cover in Azure. One is blob storage, and next one is ADLS, and next is Azure Data Factory. Azure Data Factory, and also Azure Databricks. So in the Azure cloud, I'll be covering these services. So where we'll use this Azure Data Factory or the Azure Databricks is for automation, we can use Airflow or Azure Data Factory. For transformation, this PySpark should be written PySpark or Pandas. It should be written in Glue or the Databricks. Here comes the Databricks. Databricks or the Glue. Glue also comes in different places. I mean, we can use it for transformation, automation. Glue is used in a number of ways. So Databricks I'll be covering here. And next, I will give you some overview on AWS as well. In AWS, I'll be covering S3. I'll not go in detail in the AWS because we are almost covering all the services here. Along with the Databricks, I will cover something on Azure Synapse. So in AWS, I'll cover S3 and Redshift. We'll not be using Glue here because anyways we are using Databricks and PySpark. We can write code in Glue that will become a long list. That's why I'm not including Glue. Other than this, as I said, Snowflake. Snowflake will cover in very detail at a very detailed level from basics to advanced because Snowflake is the most widely used data warehouse nowadays. Snowflake data warehouse. And I'll also cover Airflow. Airflow, most of the times we don't need to write code from the scratch. It will be already existing. We just have to make some enhancements. So I will tell you how, I'll just give some overview on how it should be used, how the pipelines are set up. Airflow. And then I think I have covered almost all of them. And also I'll give some basic idea of the reporting tool like Power BI. We don't have to be very good at a reporting tool because there will be analytics team who takes care of this reporting. But for our sake of knowledge, I'll be covering some things over here as well. Power BI. And finally, we have to, along with the Python pandas, we should also be writing PySpark code in case of big data. That also I'll be covering it while dealing with the Azure Databricks PySpark. So this is our course content. The detailed syllabus, they will be sharing it. So if you have any doubts, let me know. So hope you got some idea about what data engineering is, what we should do. Okay, if you don't have any questions, that is it for today. Stopping screen share.
So, hi, uh, good morning. I'm Vamsi.
Yes, Vamshi, tell me.
Okay, are we going to discuss about the airflow?
Airflow, yes. I'll be discussing the airflow, but not in very detail, but I'll show you the high level. I mean, because anyways, we are covering Azure Data Factory, which is a ETL tool. Airflow is like an add-on. I'll show you how to use it.
So, how about data lakes?
Data Lake, I mean Azure Data Lake, I will be covering it. Other than this Azure Data Lake, if you are talking about the data lake which is for unstructured data, that we are not taking up.
Okay. So, as you mentioned, for prerequisites Python and SQL, so how much, I mean, till core Python or advanced Python would be required, or only core Python is enough?
Uh, I mean some level of advanced Python is also required, like functions, oops concepts. Oops concepts not mandatory, better to know, but pandas we have to be good at.
Okay, thank you.
Basic along with the pandas. Yeah. Any more questions?
So, inside, I mean, while you shared, I mean, documentation in your documentation, you have mentioned like pipelines with monitoring. So monitoring means we are using uh, tools specifically.
There will be
Uh,
no tools. I mean, we have, let us say we have built a Azure Data Factory, ETL pipeline with Azure Data Factory. At one random day, the pipeline will fail because of bad data or some. infrastructure issues. So in that case, we have to go and fix that pipeline.
Okay.
There will be no tools, but we will be getting alert message on our messaging channel, whatever the organization is using. It is Teams or Slack or anywhere, we'll be getting alert. So this job has failed. We have to go to that job, look at the logs, and fix it accordingly based on the issue.
So are we thinking about Azure DevOps or pipelines for CI/CD?
No, that will come. That will come under DevOps. This is a data engineering role, not the DevOps.
Yeah, in the pipelines, right, we are using some, in order to run the pipelines, we are using GitLabs or Azure DevOps.
GitHub. GitHub. We'll be using GitHub for storing our code repository, but CI/CD pipelines or the DevOps, there will be a separate team in our organizations. They will be taking care of it. But in our course, we are not going with the CI/CD pipelines. If required, I can walk you through GitHub how we can store our data. I'll add GitHub.
Okay.
Yeah, but DevOps part we are not taking care. Because that will again become a big course for CI/CD. Any more questions? Okay, I'll stop recording.